Hey gang, in this video I want to talk about probability. We're just going to talk about some real basic probability. So here we're going to start with an example. We've got two dice. One is red, one is green. So I've got a red die, green die down here. We're rolling them. What's the probability that the red die is a 5? So what we need to think about is what are the possibilities when you roll a die. So the red die could be a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 possibilities. That's called the sample space. And then of those 6, one of them is a 5. So the probability would be 1/6. Okay. Now, if we want to know what's the probability that doubles is rolled, okay. And first of all, too, even though the green die is being rolled, it doesn't matter what was rolled on the green die. Okay, 1, 2, 3, 4, 5, 6. The green die is irrelevant for number 1 because we want to know what's the probability the red die is a 5, so really all that matters is what is on the red die. Now for number 2, they want to know the probability that doubles is rolled. So we have to think about what are all the possibilities here. Well, we could roll any of these 6 red on the red and any of these 6 on the green. That means that there are 36 total possibilities. There are 6 for, if we roll a red 1, we could roll a green 1, a green 2, a green 3, a green 4, a green 5, or green 6. So there's 6 possibilities there, 6 when we roll a red 2, 6 when we roll a red 3, and so on. So there are 36 possibilities total. But how many of those are doubles? Well, a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. So there are 6 possibilities that work out of 36 total possibilities, which reduces to 1/6. Okay? Another way you can think about it is it doesn't matter what's rolled on the red die, we just need the green die to match it. Well, there's a 1 in 6 chance that the green die will match whatever's on the red die. All right, number 3. What is the probability that the sum of the dice is greater than 8? So now we need to know the sum. So I'm just going to do this quickly here. 1 plus 1 is 2. 1 plus 2 is 3, 4, 5, 6, 7. Next row, 2 plus 1 is 3. 2 plus 2 is 4, 5, 6, 7, 8. And then we can see the pattern here. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, and 12. So we want to know what's the probability that the sum of the dice is greater than 8. So we have to look at everything bigger than 8. So 1, 2, 3, 4 that are 9, 5, 6, 7, if we add the 10s, 8, 9 with the 11s, and 10 with the 12s. So there are 10, again, out of 36 total possibilities. So we could leave it like that, or we could reduce that to 5/18. So the probability that the sum of the dice is greater than 8 is 5/18, or 10/36. The fourth one. What is the probability that the sum of the dice is greater than 8, given that the green die is 3? So now we've been given this information here. Given that the green die is 3. So all we want to look at is this column right here. Okay? The green die is a 3. We know that. So there are only 6 possibilities this time. The sum could be 4, 5, 6, 7, 8, or 9. Of those 6 possibilities, we want to know the sum to be greater than 8. Well, of those 6, only one of them, the last one, is greater than 8. So the probability there would be 1/6. And number 5. Given that the sum of the dice is 9. So this time, we're told that the sum is 9. So we're only looking at these 4 values here. Okay? So this is going to be out of 4. What is the probability that the red die is a 5? So for the first one, the red die is a 3. For the second one, it's a 4. For the third one, it is a 5. And for the fourth one, it's a 6. So only one out of the 4 was a 5. Okay, so you saw a few things going on here. First of all, just a very basic probability. Then we were kind of combining 2 dice for the second one. Third one, we had to look at specific instances where it was greater than 8. The fourth one, we were given some information, and the fifth one, we were given some information that we had to use. Okay, so let's look at a few more examples. Here we've got 2 cards are drawn without replacement, so that means we're not putting the cards back, and that's very important because if we put the cards back, we'd have a different probability. So 2 cards are drawn from a well-shuffled deck of 52 playing cards. So if you're not familiar with a deck of cards, there are 4 suits, okay, clubs, spades, hearts, and diamonds. And each suit has 13 cards in it, making 52 total. Okay. Clubs and spades are black, hearts and diamonds are red. So, number 6, what is the probability that the cards are both red? So we have to start off with the first card. We have 26 red cards. 13 plus 13 is 26 red cards, and there are 52 cards total. Okay, so that's the probability that the first card is red, 26 out of 52. But now the second card, it says without replacement. So we've taken 1 card out. So that means that there are only 51 cards left for the second card. And we're saying that the first card was red. Okay, so that means the second card, there are only 25 red cards left. So we have 26 out of 52 for the first card and 25 out of 51 for the second card. And anytime we're trying to find the probability that of A and B, so the probability that the first card is red and the second card is red, we multiply those together. Okay, so let's just bring up calculator here. 26 divided by 52 times 25 divided by 51 is about 0.245. So there is, for number 6, there's approximately a 0.245 probability that both cards are red. For number 7, what is the probability that the cards are both kings? So now, this is what kings look like. For each suit, there's 1 king. Okay, so the probability that the cards are both kings. That means there are 4 kings. So the first card, there's a 4 in 52 chance. 4 of them are kings, and there are 52 cards. For the second card, again, we're down to 51 cards now, and since we picked a king on the first one, there are only 3 kings left. And just like before, we want the first card and the second card to both be kings, so we multiply those together. Okay, so, whoops, and I got rid of my calculator there, but we would multiply those together. 4 times 3 over 52 times 51. Okay, and number 8, what is the probability that the cards are a pair? So, for example, pair of kings would mean 2 kings. Well, in that case, it doesn't matter what the first card is. First card could be anything. We just need the second card to match the first card. So that means the first card has been picked, so there are only 51 cards left. The second card needs to match that. Well, we've already picked out 1 of that card, which means there are only 3 of them left. And if we wanted to, we could reduce that to 1 over 17. So the probability that the cards are a pair, 1/17. Okay. All right.